This is number 12. We've been told that DE is parallel to GF. And we've also been told that DE is congruent to GF. So let's look at what that means in terms of our proofs. We got our statements, we got our reasons. We're trying to prove the two triangles are congruent. So number 1, segment DE is parallel to segment GF. That's given. And so what that means, if we have these parallel lines, and notice we've got a transversal here, it allows us to say that like this angle here and this angle here are congruent because those are alternate interior angles. So I'm going to say that. But remember, E is the important letter in this angle here. It's got to be the one in the middle. Think of it as like connecting the dots, where you start at D, trace to E, then go to G. And what that creates is this angle, D to E to G. It makes that angle that we're trying to refer to right here. So angle DEG is congruent to angle. We're going to do the same idea. It's like connect the dots. If we start at F, then we go to G, then we go up to E, it lets me talk about this angle. G has to be the middle letter. So it's going to be angle FGE. FGE. If we traced it with our finger, it would create this angle. And that right there is the alternate interior angles theorem. That says that if you have two parallel lines cut by a transversal, the alternate interior angles are congruent. And so then number 3. On number 3, we've run out of information with this, so we can go get our next one, which was DE is congruent to GF. DE and GF was given to us. And if you'll notice, we got a side and we have an angle. We can get this last side here. So number 4, GE is congruent to GE. Why? Because of the reflexive property. So if you look, that gives me my last side. So I have a side, an angle, and then a side here. So I can now say that triangle EGF is congruent to triangle GED because of side, angle, side postulate.